Question on energy resources now. So state what is meant by the term renewable energy resource. Be really, really careful here. The thing about renewables is they will not run out, or that they can be replaced. But a real opportunity for Muppet marks here, because often as a teacher when marking these, you see reference to reused or recycle. They are not the same thing, because we are not reusing the same things. Once we have used something, there will be more of it. So it's really important that you make reference to it not running out and can be replaced, and you don't refer to it being reused or recycled, because renewable energy resources cannot be reused and cannot be recycled. Then we're shown the diagram of a hydroelectric power station, told how the water flows from the upper lake to the lower lake through a turbine. The turbine is connected to a generator. Describe the energy transfers involved in generating the electricity. So there's lots of things we can talk about here. So if we start at the beginning of the process where we're in the upper lake, so in the upper lake here, the water is going to have a lot of GPE in its store. Then as the water flows, we are going to have a reduction in that GPE. So it's then going to lose GPE, but in doing that, it is actually going to gain kinetic energy. So either of those. So now as that water rushes through the turbine, there is now a mechanical transfer of that energy to the water or to the turbine or to the generator. Now what we've got happening is in our generator, we've got energy being transferred from the kinetic energy of the water into electrical energy. So another way of saying that is that the energy is transferred electrically. So we've got 4 points so far, so that would get you all of the marks. But the other thing we could talk about is we could talk about energy losses that take place. So normally we have energy losses due to heat. So we have another possible transfer here because energy is actually wasted by heating or radiation. So we could talk about energy being wasted by heating or radiation, and that could be in the form of infrared, so of heat, or in fact it could be in the form of sound. So 5 things there, any 4 of them to get the marks. The hydroelectric station is located near a large wind farm. You've one advantage of generating electricity using the hydroelectric station rather than the wind farm. So you're looking for anything that the wind farm can't do that the hydroelectric station can. So the thing with wind, obviously when we think about it, is wind can be unreliable. So the first thing we could talk about is that the energy could be supplied more reliably by hydroelectric. Another problem that some people find with wind turbines is the noise. So the hydroelectric power station could produce less noise. And the main advantage of hydroelectric stations is because we have this great big body of water at the top, they can respond very quickly to sudden demands because they can release the water, it can move down through the tubing, through the turbine and generate electricity on demand. So hydroelectric can respond very quickly to demand. So now we're asked to think about a disadvantage of using hydroelectric power stations. So the thing to bear in mind here is because we need this water to move downwards, the location is really, really important. So actually for hydroelectric, the location is it depends on the location. So what do we mean there? It means that we need it to be in a mountainous area. In order to build the hydroelectric power station, there's got to be a lot of damage done to habitats. And part of that building of the hydroelectric power station also requires large areas of land to be flooded. So any of those 3 will get you the mark. Now we're asked to explain how the hydroelectric station and wind farm can work together to maximise effectiveness of generating electricity, because it says that the pump can be powered using the electricity generated by the wind farm. So explain how they can work together. So it's really important here that you don't rework the question. So you won't get any credit for saying that the pump can be powered using the wind farm. But what you can identify here is the problem with the wind farm is that it can't store energy. Now, if the wind farm can't store energy, what we can do though is use the wind to power the pump when the energy demand is low. And the really important thing there is that you're saying when the demand is low. So you're not rephrasing the question, but you're saying, well, okay, when the electricity isn't required, the wind can be used to then power the pump to send the water back up. In doing that, what we're doing is we're making sure that that top lake has always got a load of water in it. So effectively that becomes an energy store. So that could be something we can talk about as well. And if we've then got this great big body of water at the top, the way that we can then use it is when demand is required, what can happen is then that energy can be released from that upper lake whenever the demand is there. And then if we use those 2 things together, what we're finding here is that actually more electricity or energy can be transferred usefully. You could talk about less energy being lost or less energy being wasted. So any of those would work. So any 3 from those would get you the mark.